So the stepping stone method is what we are focusing on now in this video. So most of the time, the stepping stone method or the UV method are what we call methods for calculating the optimal solution. So usually these two, they begin after you have solved using any one of the three methods for getting the initial feasible solution, which were either VAM, northwest corner method, least cost, and the like. So now at this point you have done that. For example, you have now done all that, the initial feasible solution, and for example you have these findings that I'm going to write in those boxes to allocate. So like you can have your 175, you can have a 25 there. So these are like possible answers that you had gotten after solving with any one of those three initial feasible solution methods. Then maybe 150 there. Then sorry, I'll just adjust this certain cost here to 7 in that box. What is 175? I still need to adjust that cost to a 7. Okay, then we can proceed and say 150 there on top, another allocation. Yeah, something like this. Then they ask you solve using the stepping stone method. What we do in the stepping stone method is, first of all, identify unallocated cells. Identify the unallocated cells and make a list of them. Make a list of them either below your box or to the side of your box. So what happens is that if you've noticed, there are about how many? 1, 2, 3, 4 unallocated cells. So once you have done that, before again you make any step further, check if the number of rows and columns are also matching to the number of cells that are allocated. If you sum up your number of rows and your number of columns and then subtract 1, the formula is actually the rows plus the columns less 1. When you sum up the rows and the columns, then you subtract what? 1. The answer you get, is it equal to the number of cells that have been allocated with unit figures in this box? You'll notice that we have about 3 rows and 3 columns. If you add that, that's 6. 6 minus 1 is 5. If you count the number of cells in this box that are allocated, we have 5. So they are equal to each other. The number of rows and columns less 1 are equal to the number of allocated cells. Thereafter, we can proceed with calculating the stepping stone method, or even though it was UV, we can also proceed after gauging this criteria. So just take note of that. So now we want to proceed and now identify those cells that are unallocated. So we'll start listing them. Let me just erase some stuff on the screen so that I can now start allocating those various cells that are unallocated. So you will find that your first unallocated cell, from what you can see here on the diagram, is that cell which is having a cost of 6. So you can just like write it as you use an abbreviation of the letter C, which just stands for cell, and then you ask yourself that 6 is in which row and column. It is in row 1, column 1, so you just say C11. That's your first identification of the first unallocated cell. The next unallocated cell is the one which is having a cost of 8, and that is positioned on row 1, column 2. That's C12. Next, the next unallocated cell is in row 2, column 2, C22. And the last unallocated cell is in column, should I say column 3, but start with always row 2, column 3. So now what next? The rule is that after you have picked up all the unallocated cells, draw loops for each individual unallocated cell. You have to make loops on each of the unallocated cells. So you pick them one by one and start making loops on them. So let's go to the first unallocated cell, C11, the one having a cost of 6. So you start drawing a loop from here. Let's put a dot there. And then you want to draw a loop. The rule for the loop is that a loop can only be either horizontal or vertical. It can never be a bend line. No, it can either be going upwards or just, in the sides. That's all. It can never bend. But for a loop to make a turn, it should find a box that is allocated. That's the only time a loop can make a turn. So follow what I actually mean by that. So the starting point is always, first of all, from the unallocated box. That's the starting point of the loop. So we start. You follow my line as I'm drawing it. There we found a box, or should I say a cell, that is allocated. The loop can make a turn. We go down. Can the loop make a turn in this box? Of course not, because this cell is not allocated. So the loop will proceed until it finds a box that is allocated, and then it will make yet another turn. So it has found an allocated cell, so it can turn. It has reached here. Can it turn? Yes, it can. But the whole point is that a loop should always return back to its original position. So the best route that it can take is to still go further to the end here, which it has also found another cell that is allocated, and can easily make another turn and return to original starting point. Yeah, that's the loop. So that is how a loop looks. You've noticed it only has like vertical and horizontal lines. So once you're done with the loop, the next rule is assign positive and negative signs only on the turning points of the loop. Positive and negative signs only on the turning points of the loop. So you always start with a positive on the starting point of the loop. A positive sign is assigned on the starting point of the loop, which was that cell, meaning the next corner point is that box which has a 10 in it. Put a minus there. The next turning point is the one with a 12 in it. You put a plus, so it will be like plus, minus, like a sequence. Okay, then there's a minus there. So what next? Once you have assigned your signs, this is another rule. I hope you've been taking note of these rules. The next rule is that you shift your attention to the cells that you had assigned negative. Before that, sorry, after you have assigned those signs, what you're going to do is you start picking the cost values that are on the turning points. You start picking the cost values that are on the turning points. So like there's 6 on the first turning point, or should I say the original starting point. So you pick the 6. It's positive because of the plus. So the reason why 6 is positive is because of that plus sign that we have assigned on the first turning point, which is where there's a 6. The next cost that you pick is the 10. It's also on another turning point, but the sign that we assigned there was what? Minus. So it would be minus 10. This is just the rule. Go to the next turning point. There's a 12. There's a sign of what? Plus there. Meaning the 12, as we pick the 12, we'll take it as a positive. So it will be like plus 12. Just like that. Then last but not the least is the last turning point where there's a 4. There's a what sign? There's a minus sign there. So you're going to say minus 4. Minus 4. That's all. You've picked the values as of, should I say, the first unallocated cell that contained the 6. And that's what you do. First of all, you make that loop that we made, assign signs around the loop, and then pick out the cost values with their respective signs. And after that, it's like you make a summation of all this. That's what happens. So this is like going to be 6 minus 10 plus 12 minus 4. You like, as I said, you make a summation, you'll get an answer of 14. Positive 4. Actually, if you punch this on your calculator, you get positive 4. As they call this a net improvement value. So why we're getting these figures is that once we have listed up all these possible, should I say, values of these unallocated cells after drawing loops around all of them, the rule is that you should only stop this process when all positive values are found on these values that have separated this side outside the box. You only stop once you have found positive values. Let's proceed. Let's go to the next unallocated cell. The next unallocated cell was the one which was having a cost of 8, which is in positions row 1, column 2. position row 1 column 2. Okay, what I'm just trying to do was erase that previous should I say that previous loop. So I'm now in this cell which has a cost of 8. Let's make a loop around this. So the loop has started moving. It can only turn wherever it finds an allocated cell. So it has turned there it has turned, and should always return back to its original starting point. Another allocated cell, so it can go back up, and that's the loop for this one. So yet again, the rule states that after you have drawn the loop, assign positive and negative signs around the loop. This is the rule. Always start with a positive on the original starting point of the loop. So plus, minus, we are done. What next? Pick the cost values that are on the corner points of the loop. So we are on this cell which has an 8, so that's C12. It will have plus 8. It will come up, it will be picked according to its sign. Huh? There's a positive, it will come like that with a plus 8. Then the next one was 10, it had a minus, so minus 10. The other one, it was 12, but it had a plus 12. Last but not the least, we had the other turning point where there was a 5 in the box, which is minus 5. Then what next? Sum up those figures. You should get a value of positive 5. Positive 5 is the answer we get according to this unallocated cell, positive 5. So far we have what? Positive 4 and positive 5. So far so good, because we have been told to stop after we have listed up all these unallocated cells. We have found the values and they're all positive. We will stop. So we're just left with 2 to be sure that we should stop. 2 more cells left. Let's go to the next cell. Let me just try to erase the previous loop as well. Okay, we got the next loop, the next unallocated cell. Sorry, it's in position row 2 column 2. There is an 11 as well. So the loop starts again. I'm starting my loop. So we'll take this route for this one. We'll go this side, we'll go down, come there and there. Only touches and only makes turns on allocated cells, and that's what we have just done, and returning back to its original point. So assign signs as usual, positive on the starting point, then of course minus, plus, minus. That sequence continues just like that. Next, pick the cost values on the turning points. Of course, we'll start with plus 11. The next one was a 1, was supposed to be 7, sorry. It's a 7, that box has a cost of 7. So it's like plus 11 minus 7. The next cost value is that 4. What sign is in that box? There's a plus. I just didn't write it well. That's a plus 4. Lastly, we have a 5, which was having a sign of negative, so minus 5. Again, get the summation of that. Plus 11 minus 7 plus 4 minus 5. You get positive 8. That's the answer. Positive 8. So far, we have positive 4, positive 5, and positive 8. You'll be like, okay, hopefully if the last one comes out with a positive, we'll stop. Let's go to our last unallocated cell. Quickly, we get back to our last unallocated cell. So this one as well was here. I'll put a dot. That will be our starting point. Let's try and make this loop. So I believe it should move like that, downwards. Okay, there is an allocated cell, but the best route is that it should just proceed, go up there, and yes, there's an allocated cell. It can make another 10 and return back to the original starting point. So you've drawn the loop. Assign signs around the loop. I'm sure now you're getting familiar with the rules now. Then you put positive on the starting point of the loop, positive, negative, positive, the rule just like that. The sequence continues, and then finally a negative there. So there's a positive in the, we've now picked the cost values around this loop. So we have a positive 11 on the starting point there. We have a minus 7 that side. The next cost value is a 4. There was a plus 4. Last but not the least, we have a cost of 12 on the last turning point with a minus sign, so it's minus 12. When you sum up those values, what answer are you getting? Negative 4. Wow, this is a change. You would think, okay, we are not done, right? Because the rule says that if you do not get all positive here in these values that you're getting, then the process has to repeat itself all over again. So these are the answers. So we cannot stop here because one of the values has come out negative. So what next? So what you do is that in that case, you shift your focus on that same cell that gave you a negative outcome, and I'll show you how you treat this. You shift your focus on the cell that gave you a negative outcome. And what cell is this? The cell in question is that one that has that is on position what? Row 2, column 3. Row 2, column 3. Of course, it has a cost of 11. Yeah, but it's in row 2, column 3. That's the cell we will focus on. So that is the rule. You just pinpoint your focus on the cell that comes out with a negative figure. So let me show you how we're going to now handle this scenario. Cell 2, column 3. Okay, that's right. So I'll redraw the loop. The rule is draw the loop once again on that same cell that gave you a negative outcome. So I'm drawing my loop yet again. That's the route it took. What next? Assign signs as usual, plus, minus, of course, around the corner points of the loop, and the plus there, and the minus there. Then the rule states that after you have done this on this same loop, next we want to change the appearance of this whole, should I say, matrix or the whole box. So what we're going to do is that we shift our focus to the corner points of the loop that had negative signs. The corner points of the loops that had negative signs, that is the one which has should I say, units of 175 there and units of 150. Yeah, and you shift your focus on only the units. You only look at the units that are on the corner points that have negative signs. So you have the unit of negative 50. Sorry, you have the unit of 150 and you have the units of 175 on the other corner point that has a negative sign. Then pick the least of the two. Pick the least of the two figures that are on the corner points of the loop having a negative sign. In this case, it's the 150. What do you do with this 150? The rule states that this 150, what's going to happen is that you go adding and subtracting it around the loop based on the sign that it finds there. You will go adding and subtracting the 150 around the loop based on the sign that it finds at that corner point. So let's start with the same point where the 150 is. There's actually a sign of minus there, right? Meaning that 150 which is going around the loop will start from here. 150 minus what units are there? 150. So it's only applying to the units that it finds on those corner points, and the sign that of course will be there. So like here there's a sign of minus and the units are 150. So 150 minus 150, this cell will now have a unit of 0. I'll come and show you the change. And then next it goes to the next part of the corner point which has a positive sign. Are there any units there in the next corner point that has a positive sign and has a cost of 11? There are no units currently, but the rule is that the 150 is going round, adding or subtracting based on which sign it finds. So thereafter, there's nothing there in that cell, but there's a plus sign. So it will be like 150 plus 0, leaving us with 150. Next, the 150 jumps to the next corner point of the loop where you have units of 175. What do you do there? There's a minus sign. The 150 is supposed to go around adding or subtracting whatever sign it finds there. Here there's negative, so it's 175 minus 150, giving us 25 left. That's the one we'll come and allocate. And thereafter, we have the last point there where there's a unit allocation of 25. The sign is plus. So we said whatever sign it finds here, there's plus, so it'll be like 150 plus 25, giving us 175. Then what we do is that we will erase our matrix, and then we'll come and allocate like new amounts on these points which we have just changed right now. Then those that remained untouched in this whole box, like if you notice that 150 which is on top having a cost of 10, it has not been untouched. So like when we redraw the matrix, that one which had a cost of 10, that one, the 150, it will just come back the way it is because it was not tampered with. Then these that we have tampered with, the one we're telling you that when you when you want this, you work with the 150 around the loop, you'll find that we'll have different values. Yeah, so it's just to clarify the point, you can rewind this video, listen to the points again on how those figures are going to change, that of how I'm now going to rewrite them with a new matrix or a box. So you're now going to rewrite those points that you know you had changed. So after there was a 175 previously, but after we had operated the 150 throughout, it changes to 25 now. Here there was a certain 25 previously. After we had operated the 150 around that part, it had now a cost of 175. This point has now 0. That was the starting point of that was the point where there was a 150 and there was a minus sign, so it was like 150 minus 150, 0. So there will be nothing this time around according to the new changed, should I say, box. And then the next one where there was a cost of 11, there was nothing initially, but now when the 150 was worked around that loop, we now have a allocation of 150 there. So this is your new, what they call a new iteration. Yeah, so from your new iteration, these are now your new allocated boxes. Then you repeat that process again of, first of all, select the unallocated cells. We start again, select the unallocated cells. The unallocated cells are as follows. We'll get, okay, the first unallocated cell is in C row 1, column 1. The next unallocated cell is in C row 1, column 2. The third one is in C row 2 and column 2. Then lastly, row 3, column 3. I just forgot to put a figure here. There was supposed to be 100 here, which was also untouched from the previous box. So these are your unallocated cells on your second iteration that you have drawn. And you repeat the same process. The rule is draw loops around the unallocated cells, and you do that same process of, let me just do that first. They say you draw loops along your unallocated cells. There you go. We started with the first unallocated cell. We've drawn a loop, assign positive, negative signs. So positive, negative, positive, negative, that sequence. And then what next? Pick out the cost values around the loop there and start summing them up. So the first one, there was a positive one, a cost of 6, so you say plus 6. The next corner point, there was a minus sign. What cost was there? 10. The next corner point, there was a plus. What cost was there? There was 11, so say plus 11. The last corner point, there was a cost of 7, sign minus, so minus 7. That's what we do. After you've had all your allocated points picked, the next thing you just do there is, as we said, you assign signs around the loop. Then you just pick the costs that are on the corner points according to the signs that are allocated. So again, if you sum up that, you should get a figure of that's going to be 0 this time around. Next, let's go to the next unallocated cell, C12, the 8. Let's see which loop that will be made on the 8. So okay, follow this loop. Well, it can only turn wherever it finds corner points and should return to the original point. Have you seen the loop it has made there? It's this shape. I'm drawing it here on your right hand side. If you look, that's the shape it has made. So this is also a feasible loop. Mind you, it has vertical and horizontal lines, so it does satisfy the rule for loops. So a loop can even make a weird shape, but as long as it has vertical and horizontal lines. So that's the loop around this 8. Then you start putting the signs as usual. Plus, minus. Of course, plus is always on the starting point of the loop. Plus, minus, plus, minus. Okay, another plus, then a minus there at the end. Yeah. So thereafter, again, you start picking the cost values that are on the corner points of that loop. So maybe just due to space, it might not really show much how I'm going to sum these figures, but what I'm going to I'll just explain by word of mouth there. So like on the first corner point, there's a cost of 8. That there was a cost of 8 means like there was a plus there, always the starting point as plus. The next corner point was 10. The sign was minus 10. As usual, you go with the same sequence. The next costs below there where it's turning, there's a cost of 11, but plus sign, until you cover all the points with their various signs, all the costs that were on the corner points. When you sum them up, this one was given a value of, you should get positive 1. just positive 1. Next, the next unallocated cell is this one, which has a cost of 11. What loop can be drawn around that one? There's this one here, follow this loop. Okay, it has returned to the original point. Signs plus, minus, plus, minus. So of course, pick the cost values around the corner points. There's an 11 there, so plus 11, plus another 11. Oh, sorry, plus 11 minus 11 this time around. Okay, because there was a minus there on the other 11. Sorry, I got carried away. And then next is there's a 12. There's a plus sign, plus 12. Okay, so minus 11 plus 12. Then finally there's a 5 on the next corner point, which had a sign of minus, or minus 5. Therefore, this one was also giving you a final value. This cell, it was giving us a final value of about positive 3. Just a minute, let me just clarify my findings. Okay, so we said plus 11 minus the other 11, which is on the other corner point with a minus sign, plus 12. 12 was on the next corner point with a positive sign. Then finally minus 5, which was in the last corner point, giving you a final answer of positive 7. So okay, so we have positive values so far. Take note, we had a 0, we had positive 1 there, and we have 7. So far so good. The last cell. So the last cell is this one, having it's in the last cell, C33. Draw a cell around that, so it can go like that, like that, like that, and does return to the original point. Assign positive, negative, positive, negative around the corner points. Sorry, they're not so clear. Okay, positive, minus, positive, minus. So the first point there, which had the cost of 12, that cell, that the plus sign, so it's a plus 12. The next one, the next corner point is where there's a cost of 4. There's a minus sign there, minus 4. The next one has a plus. The cost value is 7, plus 7. The last corner point is where there's a cost of 11. There's a sign of minus, so it's like minus 11. Overall, what's the answer? Positive 4. You sum them up. So look at the findings. Positive 4 plus 7 plus 1 and 0. Do you have positive values? Yes. 0 is just there in the center, so you've definitely reached optimality using the stepping stone method. When all positive values come out from those unallocated cells, then you have reached optimality. The last part is where you just go ahead and pick those, should I say, the remaining values in this box, like the 100 by 5, the 175 by 4, the 25 by 7, the 150 by 11, and the 150 by 10. Those, just picking up only those cells which are now allocated to find now the optimal cost, because you've now proved that okay, it's optimal, and this is going to be your final iteration, and you are done using the stepping stone method.